Greetings, everyone. Today we're going to talk about solving quadratic inequalities. I do have a foldable for your notes just to make it a little bit easier, so you have the questions written down already. All right, so our goal today is we're going to solve a quadratic inequality. So we're going to combine our solving rules and steps and inequalities with our solving quadratics and our factoring rules we've already been working on. We're also going to write our answers in interval notation. You know what that notation looks like, but we're going to have to approach it just a little bit different today. Let's go through the steps for solving. You have a spot for this on your foldable. Step one is always going to be to write the original inequality as an equation. Okay, so for the time being, we write it as an equation, make the math part, the calculating, a little bit easier. Step two is to set equal to 0. So we're going to have a quadratic equal to 0, which means in order to solve, we're going to probably have to factor, break it down, solve for x. And most likely we'll get 2 solutions. Step 3 is to plot the points on a number line and use test points in each interval back into the original inequality. So that'll make a little more sense when we actually use it. But we're going to have, if we have 2 solutions, we're going to have 3 test points, and we want to see which interval actually works. Step 4 is going to be to write the answer or the true part in interval notation. So pause the video here, make sure you get those steps down, and if you need to, re-listen to this slide. All right, let's go through a few examples. Let's start off pretty simple here. I need to solve this inequality. Step 1, as we mentioned, was to get rid of the inequality and just make it equals for now. So this is temporarily equals. Step 2 is we want to solve. Well, in order to solve, I need to move everything to one side. So I'm going to add 4 to both sides. So simple because I only had one move and now it's equal to 0. Well, if I actually want to solve for x, I need to factor first. Okay? In order to factor, my first terms have to be x and x. My factors of 4, though, could be 1 and 4 and could be 2 and 2. But I want my outer and inner to combine to get me a 5. So I'm definitely going to have 4 and 1, but my signs are both going to be negative. Remember, it's backwards foiling. So if I foil to check my answer, outer's negative 1x, inner's negative 4x, I get negative 5x for my middle term. So I'm confident in that. Well, now let's actually solve. So I'm going to have x minus 4 equal to 0, and I'm going to have x minus 1 equal to 0. I'm going to end up with a 4. I'm going to end up with a 1. Okay, so those two values have now created sort of our possible intervals. So think of a number line here for a second. Create a number line. Make sure the numbers are in the correct spot. Now, what I've created here is 3 intervals. 1, 2, 3 sections of graph that could work as solutions. So I need to pick a test point in each interval. Try to pick the easiest number. So for example, if I'm talking about numbers that are less than 1, I'm going to pick a test point of 0. Okay. Between 1 and 4, I'm just going to pick 2 as my test point. And after 4, greater than 4, I'm just going to pick the next number, 5. Okay. So to test these, we plug them back into the original inequality. So if I test 0, that would mean I have 0 squared minus 5 times 0 less than or equal to negative 4. Well, 0 minus 0 is 0. 0 less than or equal to negative 4 is not true. So this interval is a no-go. All right? It doesn't work. I could test another point if I wanted to really prove the point. Now I'm going to test point 2. That means I have 2 squared minus 5 times 2 less than or equal to negative 4. Gives me 4 minus 10. 4 minus 10 is negative 6. Is negative 6 less than negative 4? Yes. So that test point's good to go. And I can make an assumption here. You'll notice there's a pattern, okay? So let's test 5 to see if we have a pattern. 5 times 5 less than or equal to negative 4. That gives me 25 minus 25, which is 0. Is 0 less than or equal to -4? No. Okay. You should see this pattern of no, yes, no, or yes, no, yes. Okay. Very rarely do you see two no's and two yeses next to each other. So keep that in mind. If that happens, I would double check my work. So step 4, we are going to write our answer in interval notation. If this is my one true interval, then I only need to write one interval from 1 to 4. And then I have to decide, would it be brackets or parentheses? Because it's or equal to, we would use brackets. All right, let's take a look at another example here. First step is going to be to write this as an equation for the time being. So I'm going to say equals 33x. And then we want to solve. So to solve, I need to first kick everything to one side. I can't solve without doing that, okay? Now, in order to actually solve for x, I have to factor first. First check, is there a GCF? And there's not. Darn it, because guess what? That means I have some options here. Because the factors of 4 are 1 and 4 and 2 and 2. Okay? The factors of 8 are 1 and 8 and 2 and 4. Okay? So I might have to do a little guess and check. Here's some hints though when doing that guess and check. Look at your middle term. Your middle term's big. Let's think about the biggest numbers we have here. I have a 4 and an 8. What does 4 times 8 get me to? 32. Ooh, 32 is very close to 33. So I think I need to have a 4 times 8 somewhere. So that means I got to use the 4x and the 1x. And if I'm going to multiply 4 times 8, that means my maybe outer would have to be an 8, which would mean this would have to be a 1. Again, if your thought process doesn't flow that way, try straight up guess and check. Plug in some numbers, see what happens. You don't have to guess and check every one, right? Because when you guess and check the first one, it's going to narrow your scope. And you're going to be like, wow, that's way off. Let's try something else. But you should never end up testing every option. It's kind of deductive reasoning. It'll eliminate it down to fewer choices and fewer choices. But now I gotta look at my signs. If my last term's positive, but my middle term's negative, they have to both be negative. So a quick FOIL to double check. First, outer, inner, last. Hey, that works. That checks out. So let's actually solve, which means I have a 4x minus 1 equal to 0. Sorry, my writing's bad today. And then I have a 1x minus 8 equal to 0. So I have a 4x equals 1, which gives me x equals 1/4. You can have fractions. And then here I end up with x equals 8. Okay, so I have two solutions I'm going to work with. Step 3, I got to see how these look on a number line and decide my intervals. So I've got a 4th and I have an 8. Okay, so let's take a look here. If I have a 4th, an easy test point would be a 0 there. In between a 4th and an 8, maybe 2, or I could even use 1. And then after 8, you could use 9. I'm going to use 10. I feel like it's a little rounder number maybe. Might be a little easier. Who knows? Now we want to test in our original inequality. So if I test 0, 0 squared plus 8, 33 times 0. So that gets me 8 less than or equal to 0. Not true. So this should be a no so far. I'm going to make a guess that the next one should be yes, but I need to prove it. 2, 8, 2. I get 4 times 4 is 16. I get 66. Definitely less than 66. When you get to that point that it's really obvious, you don't have to keep showing your test work. I'm okay if you stop there and say that this is definitely true. And then let's check our 10. So 10 squared plus 8 less than 33 times 10. So I've got 100 times 4, 408. And then I've got 330. And that's not true. So it follows my pattern. I feel good about that answer. So that means I have one interval, one section that is true. My interval is between a 4th and 8. And it's or equals to, so that means my intervals would be brackets. okay? So what this means in the end is that any number between a fourth and 8 will work in my original inequality up here. Anything less than a fourth won't work. Anything greater than 8 won't work. All right, let's take a look at one more example. All right, first thing to do is just make it an equal sign, okay? Make it a little bit easier to start working with. So equals. Now, if I want to start solving, I need to move everything to the other side instead of equal to 0, but this is really messy, you guys, okay? So I could approach it from this perspective of I'm going to subtract everything to the other side. Oh, I'm getting kind of lost here. This isn't working out. So here's what I recommend. Let's take care of these parentheses. There's too many parentheses. So x plus 3 squared means x plus 3 twice. Remember, squaring means multiply by itself. Do not distribute exponents on binomials or trinomials, anything with more than one term, okay? The right side, hey, that's just easy distributing. That's not too bad. Let's see what happens. If I FOIL this out, first outer, inner, last, I just took care of the outer and inner at the same time. This is looking a little more like something I could move everything to one side. I'm going to move all this to the left side so that I get 0 here. So 2x squared minus 1x squared, 1x squared. Subtract 6x over, and 14 minus 9 will get me to 5. Hey, that's what I needed. That is something, now that it's equal to 0, I can actually factor. Okay? You should never factor unless 0 is on one side. All right? Otherwise, you're missing a piece of information. So make sure everything to one side before you start solving. So first is going to be x and x, definitely. And then the only factors of 5 are 1 and 5. So that makes it easier, 5 and 1. Now I got to play with the signs a little bit. They multiply to be positive, but they add to be negative. So they both will be negative. If I refoil, I'm comfortable with that answer. So I'm going to set each factor equal to 0. So we get 5 and x equals 1. All right, let's set up our possible intervals. I have a 1, I have a 5. So for this test interval, I'm going to use 0. For this test interval, I'm going to use 2. This test interval, I'm going to use 6. Okay? You can choose any number in the middle, or off to the right, or off to the left. So your test numbers might look different than someone else's, but they should still hold true. So plug it back into the original. If I plug 0 into the original, okay, I end up with 3 squared, which is 9. 0 squared, 0 plus 7, 7, 7 times 2, 14. Not true. I'm going to make a guess the next one should be true, but let's make sure. I have a 2 plus 3 squared greater than or equal to 2. 2 squared plus 7. Order of operations matters. Parentheses first, so I've got 5, then exponent, 5 squared. Parentheses first, in the parentheses do exponents first. So 4 plus 7 will get me to 11. 11 times 2 will get me to 22. Hey, this is true. So far, yes. We're going to make an assumption. The next one's no. But let's make sure. If I plug in 6 for x, 2, 6 squared plus 7, got 9 squared, 81, got 6 squared, 36, plus 7, 43, doubled 86. Close, but not true. Okay, so again, I have one interval that is true. So that one interval exists from 1 to 5. It's or equals to, so it would be brackets. Okay, so sometimes, I know these examples we only had one interval, but just know that if it was the opposite, well, let's take a look. Let's continue this on a blank slide here. Okay, for example, if you did test points and it ended up looking like this, let's say yes, no, yes. Okay, that can happen. That would mean from negative infinity to whatever number is here, okay, would exist. And then maybe from that number here to infinity, that would exist. So you're either going to have one or two intervals. Okay, that's why that visual sort of number line is helpful to determine those. Okay. All right, so we've gone over 3 examples. We have some steps laid out in our notes. Make sure to check Google Classroom, see what's coming up next. Let me know if you have any questions, okay? I know we go through things pretty quickly, so my suggestion might be, now that you have it written down, maybe re-listen to an example so you're fully paying attention. And then, if you need to stay after school or find me in Saber Time or find another teacher to ask questions, don't hesitate to do that. Get the help you need. And until next time, I hope you have a good one.